start also the live stream. Okay. So shall we start, Khalid?
Yeah. So maybe I can just say a few words, Nicola, and then hand over to you for the. You did the big share of this activity. Just to remind people what we wanted to do. From the beginning, the idea was to see how quick our community could adapt to a situation like the crisis we have seen. Some of you might remember that maybe 15 years ago, when we had a very strong earthquake in Haiti, we managed to collect data and put it available. I was working with Jeff Allen, that some of you may remember at that time, who was between Paris and Pittsburgh. And with CMU, almost in a few days, we set this up, and then it was taken by the community in a more larger situation, where I have seen a lot of Haitian Creole data donated by including commercial organizations. So the idea was to see how quick we are in this. We knew that a lot of people were working on this kind of a quick customization of systems. The idea was to do that for the COVID pandemic, both for machine translation that we are discussing here today, but also for semantic search and information retrieval and semantic search. So we had, I assume, very good number of people, which is very nice. Fortunately, we had also a very good group of people willing to provide data. So it's nice that the GRC, the Joint Research Center of the European Commission, joined the team, and Guillaume managed to provide a lot of data from GRC crawls. We did a little bit of this here, but Vassilis and his team did most of it. I'm very grateful to Vassilis and the ILSP team, because they crawled a lot of data. They combined this in the aligned text that people for MT got from us. So it showed that these initiatives we can do that if we need to, and we can do that rather quickly. Today we will see the second round of this MT evaluation, and you will see what we as a community have achieved. But what will remain is basically all the resources that we collected, all the evaluation processes that Miguel, Paco, and Mercedes managed to set up, and all the know-how and the way to set up these evaluation campaigns quickly was done. So I think it's very positive initiative. We hope that we will continue at least with machine translation if the other communities have so many challenges and evaluation campaigns to follow. What I personally expect to get out of this is, at the end, the packages of the data, the metrics, the results, publications. So those who want to work on this kind of data without being obliged to join the initiative with its own timeline and milestones and constraints will be able to do so. So that's my expectation. I hope that you share some of this. But as someone who is looking to all this from far, I'm very grateful to all the teams that did the organization job, but also to those who participated. So thanks again. Nicola, the floor is yours.
So thank you very much, Khalid. I don't have much to add with respect to what Khalid already said, because he really touched the main motivation and main achievements of what we have done in these months. I would like to underline some very positive aspects. It was not just an exercise, but so like trying to see if we were able to build a test collection quickly or under pressure, something that we could have done whenever in our research activities, but it was really a reaction of a community to a very difficult moment worldwide. So we really got together to make something useful for us as a community, and also as impact after the work in terms of resources, know-how, and also people who got in contact. Because I mean, I knew, for example, some of you, but I didn't know some others, and we really managed to work together as a team in very short time, mostly on a voluntary basis, and we got engaged with very active participants who really put a lot of effort in doing their runs. As Khalid said, we originally envisioned 3 tasks, one of information extraction, one of information retrieval, and one of machine translation. All the tasks delivered the first round, so at the Herranz, and we had basically a first round meeting almost 1 year ago, and only MT succeeded to deliver the second round. There can be different reasons for this. One thing that is for sure a motivation is that information extraction and information retrieval require a lot of work for creating the ground truth. I mean, in MT, you can reasonably align sentences in a computational way, then you have to do quality checks on what you have done, while in information retrieval and information extraction, you really need a lot of manual annotation time. And those of you who volunteered in the first round to do these annotations really know how much work it was. So that was something difficult to sustain for a second round. As you all know, we have also adopted an as open as possible approach to the resources created. So we have Git repositories for everything done by the participants and by ourselves. They are public. Everybody agreed to have to share what they did under Creative Commons licenses. So code, runs, data sets, etc. They are available. And this is something that could be exploited also after the end of this initiative. Always thinking that we can follow up with other evaluation tasks or teaming up with fora where evaluation activities are conducted. As Khalid also said, I would really like to thanks very much all the people in the organization team who have worked very hard over these months, and also the participants who have joined us in this journey. I think now it's Miguel or Mercedes.
Nicola, any words about the publication, or Miguel will do that later?
What this is something Miguel can discuss later, but one of the plans we had initially, and we didn't abandon that plan, was to come up with some proceedings For this reason, during your work, we asked you to keep a rolling report of what you were doing in order to start already working on this possible publication. If you are interested and especially willing to commit to do an additional bit of effort, what we could do is, for example, to prepare a volume in the CIUR WS proceedings. They are online proceedings, open source, but they are indexed by DBLP, Scopus, etc. So that would give visibility and a proper format of to the work we have done in these months.
So we will come back to that with Miguel, Mercedes at a later stage. Thank you.
Okay, thank you. So do you want to start, Miguel?
Yeah, sorry, let me share the screen. Okay, so hello again. We wanted just to give an overview of this round. So we'll start with a little bit of an introduction, which you already know that our main goal, as been stated, was to create an MT system focused on the COVID pandemic. And here we have a few examples. So what we tackled these language pairs, and the novelty for this round was that we added the English-Arabic pair, where the other ones from the past round. And we did two different categories: the constraint category, in which participants were limited only to using the data provided by us, and the constraint category, in which you could use any kind of data. Constraint category was compulsory, and the unconstrained was optional. So regarding the corpora, later Vassilis will comment about the data crawling, but what we did was, from the crawling, we removed all the outlier segments, and we selected the best ones according to the alignment scores for validation and test. And we balance those segments in order to have the same representation, because the crawling came from different sources. So we try to have the same representation as balanced as possible. And here are the data statistics, which the most important thing to get is that both German, French, Spanish, and Italian are the bigger ones with bigger data, around 1 million up to 3 million, while these other three are smaller, especially Swedish and Arabic, which have less of 500,000. For evaluation, we conducted automatic evaluation using BLEU, TER, and BEER, and we applied ART, approximate random estimation testing, in order to study the statistical significance and create the cluster that we will talk about that later. So Mercedes, do you want to talk about the submissions?
Yes, I will talk about the participants.
Oh yeah, sorry, I forgot about the baselines.
Baselines?
Yeah, we created two different baselines based on standard transformer models. In one of them, what we did was we limited ourselves to using only the new data from round 2, and the other one we use both the new data and the data from the past rounds, except of course for the case of Arabic, which there was only round 2 data available. And we trained the system using OpenNMT Pi, and we use BP of 3000K size.
Okay, now I will continue with the descriptions of the participants' approaches. One of the teams that got better results was LC, Lingua Custodia, They participated in the constraint option for all the language pairs of the competition. They did a pre-processing, cleaning the data, and they included inline casing with the information of the case. They also added a language token tag for each source text to indicate the target language of the translation for the multilingual models. They used a standard transformer as well. In SOC-I, they used in the first round the sec2sec-pi, but SOC-I has better data loading and support for multiple GPUs. They had 3 types of models: the bilingual that got better results for languages with more resources, such as Spanish, French, and German. Also, they had multilingual models, one type including 5 language pairs, where they excluded Greek and Arabic due to the script. And in this kind of models, Italian and Swedish benefits from the multilingual models, and even more when they oversample with these languages. And they had another multilingual model using the 7 languages that we provided. And for this, Greek and Arabic benefits, and also even more with oversampling. The results that they got were that with vocabulary sizes 40K and 50K improve the results. They were the first in the ranking for Spanish using the bilingual model. This is because we had a lot of data for Spanish. And they were also first ranking in German, but also the German model was very good in bilingual. And Italian was good for the 5, it was the best for the 5 language multilingual model using fine-tuning. And also they ranked the first for Arabic using the 7 language multilingual model. Can you pass the slide? Thank you. So the next participant is e-translation. They participated for constrained and unconstrained modes for 6 languages, all of them but Arabic. They process cleaning for the data, also checking numbers if they are in source and target, and they added a language identifier. This is for the multilingual models. They used the architecture, the transformer and big transformer architectures in Marian NMT toolkit. They added for unconstrained mode Taos Corona dataset, Opus EMEA, and a health subset from Euramis Corpora. They got better results for the big transformer for modern ensembling. Another curiosity is that they did a post-process just to normalize the punctuations, and they improve in several languages and also for 7 BLE points for French in unconstrained mode. They ranked the first for German in unconstrained mode as the first round, and in this system they used WMT data that we saw that our data talking about COVID is not far from news data. So this is why they got good results. And they also fine-tune the system with constrained data. But they talk in the paper that without this fine-tuning, they are only 1 point behind from their first submission. And also they ranked the first in all the languages, but Greek in unconstrained mode. And first for French and Swedish for constrained mode. And next team was CDT-ALS. They participated for unconstrained and unconstrained modes. They used generic and public health CDT data for unconstrained systems. And they process a cleaning approach for the data. And they use for training big transformer using OpenMT from TensorFlow. The last team, next team is PROMT, using that they participated in constrained and unconstrained modes for all the languages. They used a transformer architecture, multilingual models using single encoder and a single decoder in Marian toolkit. They process fine-tuning for the language pairs, improving 1 to 2 points of BLE in constrained mode. And their systems of unconstrained mode remains as the first round, that this team was very good in first round. And they ranked in this round first for unconstrained mode in Greek. Next. And this is the last team, CUNI-MT. They also build multilingual models using transformer architecture in Marian NMT toolkit. They process a training jointly with all the languages. The constraint mode results are better for transfer learning models. And they concluded that pre-training a model on a different language pair, because they were testing if pre-training models in a language pair and trying in another different language pair. And in this case, they obtain better results when the corpus size is big. And they also saw that transfer learning works also for completely unrelated languages. Okay, so now Miguel will continue.
Yeah, let's go to see the results. I mentioned before that the evaluation was conducted both with using BLEU, TER, and BEER. And in the report, we present the results with different tables for each metric, but that's a lot of tables. So here we have included only the results with BLEU, and we will comment something about the TER and BEER, because the behavior is mostly the same. As I was mentioned at the beginning, what we do is, like in the past round, we create cluster according to the statistical significances and rank the participants accordingly. excuse me. So the first scenario is English-German. And here we have 12 different systems were submitted and 4 different participants. And the base approaches were based on multilingual models and also some ensembles. And in this case, both the TR and BR metrics have a similar behavior. I mean, the clusters might be a little bit of difference, and participants inside a cluster may move positions, but it's the same behavior. Let's move to English friends. It's here we have 9 different systems from 5 participants. And in this case, the best approaches are monolinguals, probably because French, if I recall correctly, was one of the bigger sizes for training data. And here, in the case of TER, results are similar, but there are fewer clusters. If Spanish is similar to French, and it was another one of the big ones. So best approaches are the monolingual, but also the multilinguals. And here is the only exception in which TER behaves differently to the other metrics, and is that there's above the baseline, there's only one cluster with all the participants. There are no statistical significant statistical differences between the different approaches, only those that are under the baseline. The next case is English-Italian. We have 11 systems submitted from 5 participants. And here again, the best approaches were based on multilingual models. And TER and BR had also similar behavior. Some of these individual clusters were grouped, so there were some fewer. English to modern Greek, and here, since this is the amount of data is reduced, the best approaches were only the multilingual ones. We have 12 different submissions from 5 participants, and there are not significant differences with one metric or another. With Swedish, it's also similar. The best approaches were the multilingual, and we also have 12 different submissions. And what's more, the TER presents a few differences with a reduction of clusters, but the behavior is similar. And the final category was the newer this round, English Arabic. And in this case, it was we received less submissions, only 8 systems for participants. And once more, the best approaches were based on multilingual models, and they presented fewer clusters. And here in the unconstrained category, in this case, there was only 1 submission. And that's it. So Mercedes.
Yes. So I will present the conclusions. We have addressed 7 different language pairs for this second round, and 2 categories, constrained and unconstrained, for data usage. 5 teams participated in this round. Mostly they describe a cleaning process that improved results. We also saw that transformer and big transformer architecture provided good results. And we saw that less resource language pairs, such as Swedish, Greek, and Arabic, benefit from multilingual models. And that's all. We will continue with the presentations of the participants.
No, there is no time for questions.
Oh.
If you have any question?
I don't know, in YouTube, maybe people also can write. Or...
hello, everyone.
Hello.
Yes, can you hear me?
Yes, we do, Alexander. Go ahead.
Yes, hello. Thank you, Mercedes and Miguel, for the presentation. I have one question. So your baselines, Transformer and Transformer Plus.
Yes.
So Transformer Plus, as I understand, it uses data from both rounds. Is that right?
Yes.
Exactly.
Okay. Did you notice that for different language pairs, so the models behave differently in terms of blue? So, like for example, for the English-Spanish, Transformer is better than Transformer Plus.
Yeah.
Yeah.
Something.
Yeah. So did you address the issue? Do you have any insights why this happened?
Yeah, thank you for the question, because we wanted to make some comments, but we totally forgot. Because our initial idea was that if with the Transformer Plus, since we have more data, it could lead up to better results. But we were surprised that in some cases, like the English-Spanish, that's not the case. And we think it's because with the second round data, we clean the data better than in the past round and make the test more balanced. So I think that it's because the round 2 data is more representative of the test. So I think that's the reason why the round 1 doesn't improve much the results, because the round 2 data is already good enough, especially in those cases in which, as I mentioned before, I think for Spanish, we already had like 3 million data. And I don't have the numbers from the past rounds, but the increase was not as significant as it could be for other languages. So I think that could be the answer.
Yeah, thank you.
Just one comment. If I'm not mistaken, it's been quite a while since I worked on this project, but I think the round 1 test set and dev sets were in the second round's training set. So if you're validating your models on the whole dev set, I think that would give a wrong impression.
The word in the we took into account that round 2 data was not repeated with the previous round, I believe.
Yeah, we can double check it again, but I think the dev sets and the test sets of the first round were in the second round's training data.
They were, okay. So
I have to really double check it, but I think that's what I remember.
If they were not, that was not on purpose.
Yeah. In any case, when I was doing my validations, I had to remove them.
Yeah.
So I had to validate only on the second round's dev sets.
I think we had this discussion, and we felt that maybe dev and test could go into the training for round 2. But as Miguel said, we need to check whether this was implemented or not. I can't remember the argument, but we thought that maybe the dev and test from the first round, once it has been used, could go into the training of the second round. But better check that. Yeah,
what I do remember is that what we did was allowing the use of the first round data to all data, but we did not. I think we did not include it explicitly into the second round data.
Okay.
That's at least that's what I remember.
We can double check it. Yeah, it's not a big deal. It's not a big deal. It's not about the second round data. The most important is the second round's dev set and test sets.
Yeah.
Which they were clean.
Okay, I don't see any hand up right now, so maybe we can come back to the discussion later on, unless you want to say something more, Mercedes, Miguel, about this part.
No, not really. So I'm going to stop sharing.
So the program.
I think this one was Vassilis.
Yes, thank you, Miguel. May I share my screen? Okay. So, hi everyone. The presentation is about the data that were provided in the context of this initiative for the machine translation task. And let's start. Okay, from the aspect of data collection, unlike other cases of data acquisition, the MLIA COVID-19 case took all shortcuts in order to simulate a very quick response of the MT community to an emergency like the current pandemic. This is the reason that we decided to generate collections of parallel corpora based on available sources related to health and medicine, from which we generated the so-called general subset, based on content related to COVID-19 from well-known multilingual and bilingual websites aiming to construct a subject useful for domain adaptation, and based on comparable outcomes of available infrastructures which monitor news articles related to COVID-19, again aiming to construct a dataset useful for domain adaptation. So regarding the general subset, let's say, as you probably remember, in the first round, we generated an updated version of the MEA corpus by harvesting the website of European Medicines Agency and by applying new methods for text extraction from PDF files, identification of sentence pairs, and parallel corpus filtering. Moreover, medical and health-related multilingual collections, which were offered by the Publications Office of EU, were processed in a similar manner and increased the volume of this general subset of the data. Now, regarding the COVID-19 subset, we decided to crawl some websites. So the first step was the identification of multilingual and bilingual websites with such content, and with the aim of constructing datasets that could be publicly available, we targeted websites of national authorities and public health agencies, and you can find this list of organizations in the by following the link at the middle of the slide. We also crawled EU websites of EU agencies and some specific broadcast websites. In the second round, we acquired more data by recrawling these sites, but also by crawling websites of several international organizations. And now regarding the new, let's say, part from the second round, which we call News on COVID-19. Again, having in mind to simulate a quick response of the MT community to the pandemic crisis, we exploited the outcomes of an available infrastructure, namely MEDICIS, Medical Information System. Just to read this sentence, I think it deserves that MEDICIS is one of the publicly accessible systems of the Europe Media Monitor, which processes media to identify potential public health threats in a fully automated fashion. So thanks to Guillaume Jacquet and his colleagues, datasets of metadata which concern COVID-19 related news and contain millions of news articles stored in XML format were made publicly available. And you can find the datasets and their descriptions by following the links at the bottom of the slide. When this work was carried out, there were available datasets for 10 months from December 2019 to September 2020. It is important to say that Medicis categorizes the metadata datasets according to the publication date of the news articles into groups concerning a month or a 2-month period. So keep this in mind. Keep in mind this information about grouping, because it will be useful in the next slide. So the processing steps are the following. First, the metadata were parsed and the URL and language of each article were extracted. Then each web page of the targeted languages were fetched and its main content was stored in a text file. And next, the generated text files were merged to create a single document for each language and for each period. Now, these documents are, documents after merging are COVID-19 related monolingual corpora and could be considered comparable in pairs due to their narrow topic, COVID-19, and the fact that they were published in the same time period, meaning in the same month. Thus, we again exploited multilingual embeddings to mine sentence alignments, and finally adopted filtering criteria to eliminate noise. And the last slide with a few comments on the collected data. Having in mind first the nature of the source data, which consists of news articles that might have been partially translated many times and republished on several broadcast websites. And second, our aim, which was to extract parallel sentences from comparable corpora. We believe that the resulted corpora mostly include correct sentence pairs, but also include partially translated pairs and cases of free translations. And of course, some noise that we did not manage to remove. At the same time, it is likely that the data excludes sentence pairs that is in, let's say, the news domain, the general domain, with phrases like, Minister is expected to announce new measures on Monday afternoon. And this is not, let's say, related to COVID. This can be considered a news domain. So that's it from me, and with the wish that no new measures will be needed, I'm reaching the end of this presentation. And before closing, I would like to thank again the organizers of this initiative and the participants of this task. Thanks. If there are any questions,
thank you so much, Vassilis. I think we appreciate your involvement, and I will extend the thanks to Guillaume and Marwa for the part they did in due time when I can see them. But this is really a great achievement, and since the data and the packages will be available as such, or in the framework of this evaluation package with the results, with whatever we can repurpose, it's really appreciated initiative. Thanks a lot.
You're welcome, Khalid. Thanks. Thank you.
Miguel, Mercedes, I think the floor is yours again.
Thank you, Vassilis, once more. I think the next, we are going to start now with the team presentations. The first one was team CDT-ALS with Zuzanna.
Yes. Hello, everyone.
No.
Hello. So you will share my presentation, or how will work that?
Yeah, you can share your screen.
Okay, so let me moment, because I thought you will upload it and show it. I understood.
Yeah. Oh, sorry.
Wait a moment.
We are a small group today, so we can take our time and make it comfortable for everyone.
Okay, so I'm ready. Let me share. Share screen.
Okay, you can see it well?
Yes, we do, yeah.
Okay, good. So my name is Zuzanna and I work in the...
Put it full screen.
Sorry. Wait now. So I work in the Translation Center for European agencies. And what we do is translate documents which our other agencies send us. So it's protected data, let's say. So this is one of the reasons that we implemented our engines. And also we work in very specific domains. So basically we train our models with our clients' data. So yeah, we did it basically because for a long time the translation center was
Zuzanna, sorry to interrupt you, but I think that if you are moving the slides, we cannot see it. I think we are seeing some static version.
You have probably two screens, Zuzanna.
Just one. Main goal, you see the...
Can you just go for this Control L just to go into a full screen? Because we still see the PDF comments.
Sorry, I don't get used to work with
unless you're using a Mac.
Yeah.
No.
That's fine.
Okay, so let's see. And if I change the slide, you see?
Yes.
Okay, fine. So as I said, yeah, we build this engines just to accelerate the decrease the translation effort. The translator can pre-translate the documents, and later then they do little effort to pre-process. Actually, we are very happy with the quality of our engines. It's really very helpful for our translators. We do a human evaluation also, so we see that the post-editing effort is very low. And yeah, this competition actually we participated just to check how does it work with the external sets. And yeah, we see that maybe it doesn't work that well as we supposed, but yeah, what we can say, we didn't train. Anyway, I will tell you a whole process how we did it. So yeah, we work in 4 domains. Generic domain, we translate always from English to other language and from other language to English. Public health, we translate from English to other language. Intellectual property is the bidirectional translation from English for 4 languages only, and legal also from English to other languages. So yeah, we have a lot of own data, a part of the provided by the competition. So yeah, we have millions of our own data. The point is that it's not in the same domain. That's true. For this competition, the domains which we used was the generic domain and the public health. So yeah, we don't use data. We don't have data for Arabic. So we just some submission was only for other languages apart of Arabic. And in general, our data has 5 different qualities. First of all, the first one is validated by our translators from our translation memories. Later, we have same from our translation memories, but not validated. Later, yeah, it's going down the quality until we even generate the synthetic data with the lowest quality we have. So this is the implementation of what we did actually. It's very similar to the way we do the training in our agency. So first of all, we do very extensive data preparation. Yeah, first of all, we extract all the data we have. We clean it by, I don't know, length ratio between source and target language sentence. We remove the duplication. We normalize. We extract some tags, for example, the TMX tags like or other HTMLs or numbers and so on. Everything we can normalize, we do it. Later, we train also the sentence piece model for alignments. We filter data. For example, we use usually we use clustering to train the clustering model with good quality, like first quality. So we do the clustering, and later we remove very some threshold. We fix some threshold to remove the sentences, which are with the highest distance for the center of the cluster. And usually we train the generic model with all possible data, legal, public health, and so on. And later we fine tune with our in-domain data. And usually is validated with automatic tests. And in addition, we do the human evaluation. For this competition, we just did the automatic evaluation. So for this competition, we did 3 systems. First of all, we trained just one engine. We didn't fine-tune that with only the data from round 2. That was my mistake, because I thought just we can do only the data from round 2. I didn't use the data from round 1. So we already played with small disadvantage. But anyway, second system, we just translated with our already implemented engines. So we use the public health engine, and we didn't retrain it with the competition data. So it was like just with our available data. And the third option that obviously should be the best, because we retrained the generic engine with all possible data plus the data from the round 2. We included this data in the PH domain data of quality 4, because we consider that this quality wasn't the perfect data as we have. And later we fine-tune that with our data also, only with the PH public health domain plus the data from round 2. So the results are the following. Yeah, I included the scores and also the maximum minimum blur, number of participants, and position we get. As I said, it's not very satisfying, this results, but yeah, we didn't train on propose the engines. Only with system 3 we trained with from scratch, with including the competition data. And still, I think that we should include this data in higher quality to give it more weight, because also when we train models, we use the weighted data sets. We use a OpenMT TensorFlow version 2. So there is an option that you can give different weights during the training for different, for example, in our case, different qualities. So first quality is it's updating, having more impact on the model weights. And I think that's all. It was very fast. And if you have some questions, so don't hesitate to ask. Thank you.
Thank you so much, Zuzanna. And I think we appreciate that you joined the initiative despite the effort required to do all the evaluations, and I think we understand that you couldn't train your systems and optimize that for such initiative, but we appreciate.
That's the point. I would like to, but actually the models that we train with our data, that are millions of lines, it takes like sometimes maybe 1 week, and we have quite good machines. So yeah, just for competition, for now I have no resources to do this. Yeah. But at least we did one of them, so for the Italian, so yeah, at least we can compare each improvement. So yeah.
Questions from the attendees? Feel free to step in anytime. I think we
I did it very quickly and very, maybe not very detailed.
Well, we will have the slides, and we have the connections. So if people want to hear more or whatever, I'm sure that we will get in touch. I don't know.
We have one paper, one publication. So it's called NICE. It's easy to remember. So if you want to check some details on implementation, there are. It's not very updated. It's 2 years ago, I think we did it. So already we had more, more things to improve it, but still.
Okay. Miguel, Mercedes, Nicola, the floor is yours. Feel free to take over.
Thank you, and thank you, Zuzanna. I think the next presentation is from Team PROMT, Alexander. If there are no questions, we can move to that. So, Alexander, when you're ready, you can share your screen.
Sure. Just a moment.
Yeah, don't worry.
So, can you see it now, the presentation? Yeah. So everything's good. Yeah, I can start.
Yeah, when you're ready.
Okay, so yes, once again, I'm glad to see you all. My name is Alexander Molchanov. I am head of the NMT team at PROMT. This is a Russian company, well, specialized in machine translation solutions. So, can you see the next slide? Yeah.
Yes, Alexander.
Yes, you can.
Everything's fine. Yeah. Okay.
Yeah.
So yeah, my presentation will also be quite brief and short. So first of all, let me tell you about the data we used this year. Same as last year, we provided both constrained and unconstrained systems for all provided directions. Speaking about the constrained systems, actually one system. We use all provided training data for both rounds 1 and 2. We just do the deduplication. We do not apply any filtering to the data because, well, let's say we applied some basic filtering methods to see if the data is okay, and well, it seemed quite good to me. So we just used it as is. We use a shared 8K sentence piece model and So we build one single multilingual language model, and as well, I suppose everyone else, we just apply language tags to the source English side of the data. What's new in this year, we also use synthetic data, about which I will tell you in detail on the next slide. So as for the unconstrained systems, they are the same as last year. We use all publicly available data and some private data for our different systems. We do not do any fine tuning, so actually no COVID-19 MLIA data is used. And instead of sentence piece, we use our own implementation of case-insensitive byte pair encoding of various sizes for different models. So this year we decided to use back translations. So let me tell you how we obtained them. First of all, we build an intermediate multilingual X to English single model. It was built on all provided data from rounds 1 and 2. To obtain back translations, we use monolingual data from the multilingual semantic search task of round 2 of the initiative. Basically, this is the Medicis 2020 data. So we extract the data. We noticed that it was quite noisy, so we used some very simple handcrafted rules to filter this data. Basically, we discarded short sequences, long sequences, and we only kept strings which ended with a punctuation symbol, like full stop or a question mark or an exclamation mark. So then we obtained the synthetic translations of this data, and finally we scored these translations with our forward model from round 2. So, of course, except for the Arabic language, which wasn't present in the round 1 data. And we select the best scored translations and use them for training our final model for round 2. So as for the Arabic English language pair, we just randomly select an appropriate size, an appropriate amount of the translations, so that it is roughly the size of the English-Arabic parallel data for round 2. As for the models themselves, the architecture is also the same as last year. So for both constrained and unconstrained systems, it's a baseline transformer. We build our models using the Myriam toolkit. It's a single multilingual model for the constrained system. All language pairs. We use a shared vocabulary. We do some basic vocabulary filtering based on frequencies. And once again, what's new this year is that we use fine-tuning. So we build a baseline model on all languages, and then we fine-tune this model separately for each language, each of the 7 languages. So the unconstrained systems are exactly the same as they were last year. They are also baseline transformers. They are different for different language pairs. 2 of them are multilingual. As you can see on the slide, the rest of them are were built separately exclusively for each language pair. We also use for our unconstrained systems, we use shared vocabularies except for the English to Greek model and English to Arabic model for obvious reasons, because English, Arabic, and Greek have different alphabets. So as for the results, we ranked top in English Greek, quite surprisingly. Well, if we compare the results to other language pairs. So you can see on this slide our results for the English-German pair. It's quite similar to our results in other pairs, except for the English-Greek. So we are behind the Lingua Custodia, our colleagues from Lingua Custodia, and e-translation. So, well, I don't have any insights on why this is so. So maybe our colleagues paid more attention to other language pairs besides from the English-Greek pair. And finally, I would like to say a couple of words about our future work. So I would like to perform domain selection for synthetic data this year. We couldn't do this, but the data from the Medicis seems to be a bit noisy, and I think carefully selecting data from the Medicis corpus before building translations would help improving the quality. It would also be interesting to manually check fine-tune models for different language pairs for possible overfitting, because we we obtain obvious improvements in terms of blue scores, but honestly, I didn't have time to see what goes on there. Well, take a look at that. And we would probably like to try and fine-tune our general unconstrained models on the provided in-domain data. We also, unfortunately, didn't have time to do it this year. Well, and maybe according to what I have heard today from our colleagues, maybe we should take a closer look at the provided in-domain data. Maybe it does need some filtering, some careful filtering, and this could improve their results. Well, I think that's it. Thank you very much. So if you have any questions, I'll be happy to answer them.
I have a question.
Yes, sure.
Yeah, thanks for the interesting presentation, Alexandra. Actually, I have a question about the vocab size. How do you explain the fact that you use the really small vocab size, like 8K, for a big multilingual model of 7 languages plus English, and you still achieved competitive results? It's very small for me, like 8K for 8 languages.
Yeah, you see, it's still a problem for me also, because we have production models where I still don't know what the optimal vocabulary size should be. But I have a general insight at the moment that if you have small, relatively small, not large amount of data, and this is the thing with this initiative. So I think for round 2, we roughly have the data combined from rounds 1 and 2 is for all 7 languages is about, I think, not more than 7 or 8 million sentence pairs. And this is not much. And for this amount of data, well, according to my experiments, it's better to use a small, relatively small vocabulary like 8K. If you have like some, if you deal with production models like where you have 100 or 200 million sentence pairs, well, including different types of synthetic data, then yes, you should use a larger vocabulary like 32, I don't know, 30, 40, 50K. Yeah. So I hope that answers your question.
Yes, thank you.
So, well, anyway, you can see my email. You can always write to me. Have any other questions?
Yeah, thanks a lot, Alexander.
More than a question, I have a bit of a concern, because you said that you have used monolingual data in the constraint category for building the synthetic data. Is that right?
Yes.
I understand. Yeah, because technically that would be for the unconstrained category.
No, because the organizers and you in particular wrote that we could use for the constraint systems, we could use all data from all tasks.
Oh, that was from another task.
Yeah.
Okay. So then
yeah, I'm sorry, I might be misleaded, but well, I'll try to find the letter. So
no, I think it's me who understood you wrong.
So I understood that I could use all data from all tasks for any task.
Yeah. No.
Yes, so that's what I did. Yeah.
Yeah. Okay. So I understood that you had used
No,
for the synthetic. So sorry about that.
Only the data provided by you and the organizers.
Okay. So thank you for the clarification.
Okay. Yeah.
So maybe Miguel, Mercedes, we can move to the next presentation.
Yeah, so I'll stop sharing my screen. Yes.
Yeah.
So
thanks again, Alexander, and I hope we will keep in touch for whatever comes next.
Once again, thank you for listening to me. Okay.
Thank you very much.
Yes. Next team is CUNI-MT. Ivana Kvapilíková. Sorry for my presentation.
That's okay. Thank you. Hi.
Hi. Thank you.
Hi. So let me share my screen. All good? Do you see it?
Not yet.
No. Okay.
No.
Okay, now we see it.
Okay, perfect. Okay, so hello everyone. I am Ivana Kvapilíková from the Charles University, and I will now be describing the submission of our team to this competition. And so the same as last year, we participated in all language pairs. All the systems that we submitted are constrained, so we were only using the data, actually only the data for round 2. We didn't use the data for round 1, and we didn't do any special filtering. We only did some very easy filtering based on the length. So based on the length ratio, but other than that, no pre-processing. and we submitted systems from two, let's say, approaches. So we trained one multilingual system for all languages, and then we experimented with several setups of transfer learning, which I will be now giving you a bit more details about. So for as far as the system architecture is concerned, we used a 6-layer transformer with 8 heads for all our systems. Also, for all our systems, we used a shared vocabulary of 50,000 subword units. And so we chose the shared vocabulary also for our transfer learning system to enable us to experiment freely with different language combinations, because with only bilingual vocabularies, we would always have to switch the vocabulary in different transfer learning phases. So we opted for this, which was easier for us, but probably cost us some points in the final blue rankings. So for the multilingual system, we trained one system for all 7 languages, trained it jointly, and we use the language tags for the target languages, which we added for. Okay, so not tags, but we added the language information to the target embeddings. For the transfer learning systems, we always pre-trained the system on either another language pair and then fine-tuned on the language pair of interest, or we experimented with pre-training on a sequence of different language pairs. And we also tried pre-training on a mix of all language pairs, or of all the data available for round 2 for all languages. Use it all for the pre-training. Here, just a quick illustration of the transfer learning approach. So, as I said, we first, now this is an example where we trained an English-German system, but we first pre-trained it on the English-Spanish data. So we first trained it until convergence on the English-Spanish corpus. And then we switched it for the English-German corpus and fine-tuned on the data of interest again until convergence. The approach with multilingual pre-training was that we, in the pre-training phase, we created a concatenated corpus of all the languages. Or we also experimented with different numbers of languages, but in the most successful scenario, we mixed all 7 language pairs and pre-trained the system on this mix without any language information added to the system, and then fine-tuned on the language pair of interest. So again, here English-German. In the multilingual training, we just trained jointly and let the model know what language it's translating into by adding the information in the embeddings. So here, these are the results on the data set, where we can see, so these are the results of the transfer learning approach, where in the top row, we see the languages of interest, and in the first column, we see what has been the pre-training language. So from the results, we see that for actually all the languages, it was the most successful to pre-trained or on either the English-Spanish corpus or English-French corpus, which is most likely due to the fact that those were the largest corpora available. And we also see when we look at the comparison of the last row, which is the pre-training on all languages available, that this helps, but not always. So it helps in the case of Arabic, Greek, and Swedish. It helps when we really pre-train on all the data that we have. And that again might be because these three languages, Arabic, French, and Arabic, Greek, and Swedish, are the most low resource. So they have the least amount of data. So in these cases, it probably helps to really make the pre-training phase more extensive. So these are the result, the comparison between the transfer learning, the best transfer learning model that we trained, and the multilingual models, and it seems that in our setup the transfer learning models have a better results, with the exception of the English-Swedish language pair. But this also might, I don't want to make this like a general conclusion. This is just in our setup. Also, it can be that in our that our multilingual model did not the hyperparameters were not tuned well enough for this particular scenario. Here I didn't even I'm not even showing the rankings of our team, because it was actually ranking in very low, which we were sorry about. We were trying to think about like what were the reasons, because actually in round one we ranked pretty well. And so we still have to, maybe if there is another round, we would be looking a bit more into it, but it's might be the case that the shared vocabulary that we used to make our work easier to enable us the experiments with transfer learning combinations, that they actually cost us some points, and maybe also some maybe we should have also done some more data filtering or data pre-processing. And yeah, so to conclude, from our experiments, we clearly saw that all the language pairs benefit from transfer learning. Like always, the transfer learning approach was better than training just bilingually, but we saw that in the round one already. Also in our setup, transfer learning is more effective than multilingual training. Also, it seems that the larger the parent pre-training data set, the better, because we saw that French and Spanish worked the best in the pre-training phase. And also we saw that multilingual pre-training is beneficial for those language pairs which do not have too much data. For the future, what we would definitely improve is that we would work better with the data. We would try to do some more filtering or pre-processing. We might try using like working differently with the vocabulary. Also, what was said before, that maybe using a smaller vocabulary would work better. So we would also take that as a hint for the future. And also what we did in round one and didn't do now was back translation, so that most probably is also something that would be useful to incorporate in our systems. Thank you for your attention. If you have any questions, I will be happy to answer.
I don't see any hands up. So again, as I said, Miguel and Mercedes Paco will ensure that all the slides are made available, and if people want to take this kind of conversation offline, I highly encourage that. The idea of this initiative is really to learn how we are doing this quick adaptation to a new area and new vocabulary and the like. So thanks again, Ivana.
Thanks, Ivana. The next presentation is by Team LC with Rahil.
Just share my screen. Do you see my slides?
Yes.
Okay. So hello everyone. Rahil. I am from a company called Lingua Custodia. We are based in Paris with offices in Luxembourg. So basically we are Lingua Custodia. We are specialized in providing machine translation services to the financial industry, like banks, asset management companies, etc. And we have machine translation systems supporting all the Western European languages, Japanese also, and Chinese. And we have a very small research team of 3 people. This is our second participation in this challenge, the second round. Basically, as in the first round, we are only interested in participating in the constraint task. And for the constraint task, we participate in all the language pairs, all the 7 language pairs. So our goal in this challenge is basically we are trying to understand the extent of how multilingual models can go.
Okay, sorry to interrupt you, but there's something on the top of your slides that in the right part. I think it's from the background or something.
Let me just minimize everything.
Okay, now it's better.
Is it fine now?
It was before, but
because before I minimized everything, I don't see anything when I minimize. Is it that bad, or?
No, I mean the problem is that the right part of the slides are not seeable.
Even now?
Yeah, now they are.
Now it was basically the Zoom. It's a Zoom layout for viewing the participants. Is it fine now? Can I continue, or?
Yeah, it's fine. Thank you.
Okay, perfect. Go full screen again. So yeah, our goal is first to understand the extent of multilingual models, comparison to bilingual models, and then for this round, we wanted to try some different tricks like oversampling low and mid-resourced languages. And we did this by clustering the languages into different clusters. I will show in a bit. And then, of course, trying to find the best fitting parameters, especially hyperparameters for this task. And also the goal of this challenge also kind of aligns with the goals of Lingua Custodia, because we are planning to move to multi-domain and multilingual models very soon. So it kind of gave me an opportunity to understand multilingual models better. So first of all, let me talk a bit about the language clusters. The way I kind of approached the task was to cluster the languages based on, first of all, the number of training samples that we had. Second, based on the writing script. When we cluster based on the number of training samples, we can have 3 clusters. French, Spanish, German goes to the high resource. Italian, Swedish, Greek goes to the mid resource. Actually, Italian could go to the high resource too, but I think we will see in the results that they better fit this cluster. And then Arabic, the language with the least amount of resources. And then based on the writing script, okay, of course, it's easy. The Western European languages, and Arabic and Greek on a different cluster. Why this clustering? We can use this clustering, first of all, to kind of train the language in the same cluster separately. And also it kind of impacts the vocabulary and stuff like that. So the pre-processing, for the pre-processing, I followed the following list: the tokenization with Moses, remove samples where there's a big difference between the length of the source and target, removing consecutive tasks, and maybe the most important was inline casing, where you kind of lowercase everything, and to preserve the casing information, you add tasks, tags after the case token to give the information about the casing. For example, here T is for title case, and then M for mixed case. And then we apply sentence piece by forcing the model to split the letters into individual characters. Of course, we add language specific tokens as prefix for the multilingual model. And then, of course, as we describe in the paper, we try several vocabulary sizes to understand the importance of this hyperparameter. So as Mercedes was talking about in the beginning, actually, she gave a big part of my presentation. Basically, she summarized everything, but we use Sokai this time instead of the previous tool that we developed, because Sokai provides better multi-GPU support and also the data loading. We are currently trying to rebuild our neural machine translation training toolkit from scratch to add better support for multi-GPU plus better handling of the data. So for this round, we decided to temporarily use Sokai, but in the third round, if there's any round, we might go back to our own toolkit. We have both bilingual models for all the 7 languages, plus we have multilingual models. For the multilingual models, we have a multilingual model trained on all the 7 languages. And then we have a multilingual model trained on 5 languages, excluding Arabic and Greek. And then for both 7 language model and the 5 language model, we also have 2 different versions where we oversample the languages, the training data of languages that have less resources or mid resources, like Arabic, Swedish, Italian, and Greek. Hyperparameters, really standard parameters, standard transformer 6x6 encoder decoder layers, embedding size 512, 8 attention heads. We share the embeddings of the source target plus the projection layer. We use a beam size of 5 during inference, and we trained on 3 RTX GPUs. So the first results, these are the results for the vocabulary size experiments, where basically we try 4 different vocabulary sizes, and then we observe the blue score on the def set. From what we can see from the scores, as we increase the vocab size, we get better results, but then at some point the model doesn't really care about the vocab size. So there's not a big difference. There's no big difference between 40K and 50K. That's why for the end experiments, we decided to go for 40K. So in all the future experiments that I will describe in a bit, we used 40K vocab size. Then the second experiment I did was to understand that if pre-processing all the lists that I described actually adding any value, because we could be doing lots of pre-processing and at the end they might not be adding any value, but actually here we can see that the pre-processing, probably most importantly the inline casing, has a big impact. And without pre-processing this model, which I only used sentence piece, we get 39 blue score, but with the pre-processing and sentence piece we get a significant improvement. So the pre-processing apparently adds a lot of value to the whole models. These are multilingual models. And then we have the experiments on the def sets. I provide the def set results because they are more complete than the submissions. So what we can see in the results is that for English, German, French, and Spanish, the bilingual models on the def set, they always give the best results. So it means that the multilingual models are not adding much value. The other languages are not adding much value to these 3 language pairs. Then for Italian and Swedish, we can see that it's better for them to remove languages with different scripts. So in the 5 language model, we have, if you remember, I said we removed Arabic and Greek. So this benefits Italian and Swedish a lot, especially when we oversample. So this line is the 5 language where we oversample Italian and Swedish, and we do not touch the training data of the other 3 languages. And when it comes to Greek and Arabic, we see that the 7 languages we get the best results with the 7 language, again, when we oversample those languages. And then finally, the submitted systems, we observe slightly different, but still very consistent. For example, for German language, we have the 5 language model achieving our, giving our best result, but actually I don't show every detail here, but this is actually a 5 language model fine-tuned on the German data again. So it's a multilingual model fine-tuned on a bilingual data, which is kind of sad because I wanted really to see that multilingual models be enough. But in this case, we can see that even if you have a multilingual model, it's always better probably to fine-tune it on the bilingual data again one more time to get better results. And for English, for French and Spanish, same results as a dev set. We have better results when we have it with bilingual models. Italian, Swedish, again 5 languages, and for Greek and Arabic, we have the best results with the 7 language. Especially, I want to talk a bit about the Arabic language. This is really a good example of how multilingual models can benefit very low resourced languages. As you can see with the bilingual model, we have only a plus score of 19. And then we managed to take this by 6 points just by adding other languages to a big multilingual model. And this benefits a lot Arabic, Greek too. In this case, we have 3 blue point increases. So as a conclusion, what I can say is that if you want to do multilingual models, the best probably would be to cluster the languages based on some kind of similarity. It could be their number of training data, could be their writing scripts, could be their semantics or anything like that. So it's always better to cluster languages. And for some languages, you will find that bilingual models are still better. But for some other languages, you'll see that they add a great value. The second point that we found out in this challenge was that oversampling is really important if you are doing multilingual models. It's better to oversample the training data of languages where they are not heavily represented otherwise. The oversampling techniques we used are really basic. We just multiply the training data by 2 or 3 just to make them closer to the training data of the higher resourced languages, but maybe one can even try more fancy oversampling techniques. But yeah, this remains to be studied. Finally, as I was saying in the first point, bilingual models still remain to be very competitive for French, Spanish. Yeah, so this is a point that still I'm trying to solve. How can we have like a multilingual model that can be put in production that's as competitive as bilingual models? This point is still remain to be studied, and it probably take me some time to figure out to have like one consolidated model that's as good as the bilingual ones that could be put in production in the company. So basically, that's all from me. If you have any questions, do not hesitate. Thank you.
Sorry. Yes, I have a question, please.
Yeah. Sure.
Yeah, go ahead.
Yes. Can you back to the slide about the size of the vocabulary, the experiments with the different sizes?
Yeah.
Yes. What pair have been used for this experiment?
So this, yeah, sorry, it's not very precise. So this is a multilingual model with all the 7 languages.
All the languages.
All the languages with sentence piece.
Have you tested the same for each pair?
No. Yeah, no. This is purely was Michael. Yeah.
There is a hypothesis that this the size will depend of the size of the training set. If the training set is low, maybe it's better to use small vocabulary sizes.
But that's only true for bilingual models, right?
Yeah, of course.
Yeah. You are right. I didn't really have time to go that deep, but even like for English, Arabic, and English Greek, as Alexander was saying, you should probably not share the vocab. In all my experiments, I was sharing the vocab. So there are many flaws in the experiments that I did that could be done actually better.
Yeah. Okay. Thank you very much.
Okay.
Hi, once again. Well, I have a small question, but I think you probably answered it already. So when you do oversampling, you oversample so that the total amount of the training data is approximately the size of the largest language pair. Is that right?
Yeah. Exactly. But I was doing it as very naively, but by just multiplying by an absolute value like 1 or 2 or 3 or 4. So it kind of, at some point, maybe some of the languages, lower resource languages can be overrepresented even more than the high resource languages. That's why I was saying maybe one should do it more properly.
Okay. And another small question, have you tried to do any human evaluation on, like, to compare the results of the oversampled models to the models without oversampling?
That would be difficult. No, I have not done it. Okay. But that's actually a good point. How oversampling these?
It's just it's actually a general question because I didn't have time or maybe expertise to do any human evaluation for the results I get. So just basically blue scores and.
Yes, what I realized just by analyzing few languages using some of the MT tools, I don't know, it was visual. VSEC or something like that, I realized that the Arabic model kind of adds one single token to every generated sample. So like we had, it was obviously overfitting to the training data. It was adding one specific token to kind of to the front of every sample. So obviously, yeah, if you do a proper human evaluation, you'll probably discover many strange things with these models. But the blue will not tell you those.
Yeah. Okay. Thank you.
Okay.
Yeah, Miguel, Mercedes, we can move on to the next presentation, maybe.
Yeah, thank you, Rocky, once more. And the next and last presentation from the participants is from Team e-translation. I think it was going to be by Sisaba, or sorry, I don't know how to pronounce your name.
Choba, yeah, okay. So I'm
sorry.
I just try to share this screen. Can you see anything already, or is it working?
It's coming, I think.
Nothing.
Nothing yet.
Yes. No.
Yes, we see it. So now you need to go into full screen.
Yeah, I'm trying. I hope it's coming, or it's already there, perhaps. No?
It's coming, but you have a banner on the right as before. That's probably something due to Zoom.
So it's still not full screen.
No, it's full screen, but you have a black banner on the right. There must be something, some control in the background.
Yeah, that's most likely where he sees the pictures of us. But it's at the ball. Yeah. It's at the margin, so it will
okay.
Not,
that's
will
much
not
better.
really hurt.
Okay, all right. And you can see the second slide now. So if I
yeah.
So right. So I'm going to briefly present what we've been experimenting with and finally submitted to this task. And this is also going to be a pretty short kind of overview of several experiments we've been doing on the 6 language pairs we participated in, both in the constrained and unconstrained category. Unconstrained to us mostly meant adding some external health-related data sets. I will go into a bit of the details later on. I will mostly speak about the English-German submission because the rest of the languages more or less followed the workflow that we applied there. And opposed to the other participants, we didn't really fiddle with multilingual models, I think, at all. So this is a kind of another line of approach, which is still kind of more or less, or proved to be more or less successful, because we had several first positions in the rankings with the strictly bilingual models. So what we basically did was to use more or less kind of standard best practices. We actually borrowed a lot from our WMT submission workflows. Not everything, because that is kind of was a little bit of a different task, but still some basic steps kind of were directly transferred to these experiments. We try to find some optimal architecture and parameters for each language pair. We've had kind of limited human and infrastructure resources as well. So in this sense, the scope of the experiments was a bit limited. So we could have done more, but with the resources at our disposal, we did what we could. Where we actually, in the unconstrained category, we tried to play around a bit with really powerful general models. That was mostly true for English-German. And as it turned out, and you will see, it was kind of quite impressive that what the general model was able to do even on these kind of more or less domain-specific test sets. With respect to processing the data, we had some kind of causal looks, and then we saw that it was not the cleanest of parallel data, probably, and so it might have needed some cleanup, and then we focused on it a little bit and then did some pre-processing. I will go into the details in the next slide. And as I mentioned, for the unconstrained systems, we try to use all available health-related data that we were able to find. So English-German in the constraint category, we kind of can see some significant increase of the provided parallel data compared to the first round, and more than double the size. But we also kind of can also see, or we could see some noise in the data set. Some segments were rather just comparable and not parallel. And so we did some basic filtering like language identification and deletion of segments based on the source target ratio. We introduced some maximum length constraint as well on the segments, and some other kind of more or less ad hoc filters. And to filter out the segments which didn't really seem to be parallel or even perhaps comparable in some cases, we applied a very simple and basic heuristic that we checked the numeric tokens between source and target, and when there was a mismatch, we just deleted disregarded the segment. And actually, it looked pretty safe as far as the precision is concerned. So the segments deleted were really bad segments. But in terms of recall, we haven't really checked, but yeah, so we still might have left a couple of segments which were not really parallel. So after that, for English German, we had a little bit more than 2 million segments for the final training data set. For the unconstrained engine, that was one of our submissions. We used the Taos corpora, the Opus-Emia corpus, and some kind of health-related subset of the Euramis data set that amounted to another 2 million segments. The training scenario was kind of pretty standard and basic. We first used the base transformer architectures with the Marian toolkit. Basically no specific pre-processing besides the raw sentence piece subword segmentation. And we also experimented with the big transformer architectures, but again, that with kind of a standard setup of a big transformer architecture, so still 6 encoder and decoder layers and so on and so forth. Because of the limited resources and time, we only just took a look at the 2 different settings of the vocabulary size, 12,000 and 32,000, and the latter proved to be a little bit better. So we trained the models with the 32K setting. And as a last step in the training, in one of our submissions, we also used kind of a 5-epoch fine-tuning on the first and second round validation and the first round test set data. As it turned out, the best submission in the constraint category, we see the unconstrained one as well, was a 4-member ensemble built from individual big transformer models, each fine-tuned, as previously mentioned, and we used 2 to 4 V100 GPUs to train about 30 epochs for different language pairs with different number of epochs. We had 2 unconstrained submissions for English German. One was a kind of a pretty prototypical single big transformer trained on the extended data set, about 4 million segments. And the other one was this WMT 2021 new start submission model, which is a huge model trained on 400 million segments, but this is not, there is no domain specificity besides that it's supposed to be a news model, but nothing specifically health related or COVID related. Again, it's a 4-member big transformer ensemble, and one alternative setup was that we fine-tuned this general model on the filter training data for 3 epochs, and we used the same kind of ensemble architecture. So as far as the results are concerned, we kind of tried to utilize several data sets, one from the Uramis data, and the other generated from the round 2 validation set, and then the third column is for the official round 2 test set. And more or less, I mean, the results are not always conclusive across all test sets, but more or less what we did as different steps of pre-processing or training with different model architectures, this is more or less justified. So as we kind of applied more complex architectures, filtered more data, the results more or less get better. What is interesting, and I mentioned it in the conclusions as well, that this general model by far outperforms anything specifically trained from the constrained data set. The English-Swedish system was pretty similar in terms of training workflow and the data set used. So round 1 and round 2 segments, there's pretty similar filter heuristics were applied. Again, this data set actually proved to be much more noisy, and that's why the filter out ratio is much bigger. So for English German it was around 6%, but here it was 25, so almost a quarter of the data set, or exactly. Training was similar with the base and big transformer, and but the vocabulary size here it was 36K, and the unconstrained additional data was more or less from the same sources. And again, as the architecture became more complex, or the data, we added more and more data, and the results became also better. So more or less the workflow is justified by the test results. For the other language pairs, again, a pretty similar scenario. 2 kinds of transformer architectures were tested, the similar vocabulary size. Interestingly, more or less the same data sets. I mean, the provided data sets, more or less the same scenario, but sometimes very different results. So for instance, English-Greek was very bad. English-Spanish was almost the best in constrained, and the best in unconstrained scenario. And the English-French, again, it's pretty similar in terms of workflow and training scenario, but this was the best in the unconstrained and the unconstrained category as well. This was mentioned in the introductory presentation. Actually, this was true for English-German to some extent, but to a large extent in English-French. I was not very specific in the report, so it might have been misunderstood, but actually the result is opposite. So normalizing the punctuation makes or leads to the significant decrease in the blur score, which is really strange. I mean, or not strange, but kind of an unwanted side effect, basically, because with machine translation models, we don't really want to test typography, but rather the linguistic content of the translation. But I mean, actually the raw output of the model, which is not normalized, so which is the unnormalized output, was more than 7 or around 7 points higher in blue than the output. And then here, I mean, the difference here is just the dashes and the quotation marks, and nothing more, so like that. So that's not really a good kind of indicator of the machine translation performance. So it might be perhaps better to standardize test set in this respect, or I don't know. Okay, English-Italian, I mean, we put a little bit more effort into this language pair and try to experiment with the kind of clever subsets of data extracted by using some keyword patterns and use it to fine-tune the final models. But it turned out to be not very successful. Otherwise, it was pretty much the same, two different architectures and the big transformer models assembled in the end. And also for the unconstrained data set, the same sources used. And again, the results more or less justify the workflow. And in the end, the unconstrained model turned out to be the best across all submissions. So to the conclusions, mostly we focused on data selection and filtering, and basically we used really kind of standard training scenarios and nothing magical in our experiments. We still managed to build pretty competitive systems, which ended up in first place in several categories. And as I mentioned, it still seems that, at least for high resource language pairs, or perhaps not even only for high resource, but if we have a very robust, large generic system, then it seems to perform much, much better than anything else. Or I don't know, I mean, just I hypothesize that it could be due to the still very diverse and noisy data sets, which might not be just so much domain specific, because I mean, one can expect from a domain specific engine trained on 2 million segments to perform already perhaps at least on a par or better than a large general model. But in this case, at least for English German, it was not the case. It was just quite the opposite. And by that, I thank you, and I expect the questions in the end. Thanks a lot.
Hi, hello, Csaba.
I try to go back to my original Zoom screen. Yeah, okay.
So, can you hear me?
Yeah, sure.
Yeah, thank you very much for the presentation. I have two small questions. First of all, the Euramis corpus, is it the same as the DGT corpus, or is it something different?
No, I mean, it's a lot more. So the DGT corpus that is publicly available is quite a small subset. And here, I mean, for the unconstrained submissions, we use the whole Euramis as the source data set.
Is it available somehow through any license, or no?
Fortunately, it's something we cannot share. We do not even own it, because it's compiled from what other EU institutions have uploaded into a central database, which we provide as a service to all the EU institutions. So even asking them for green light to share it would be a bureaucratic nightmare, and with a very high probability of a negative outcome.
Okay, thank you. And
we're very sorry for that, but it's always a pity we cannot share what we have. But yeah,
no, it's just a question. I just have never heard of this corpus. So yeah, okay, thank you.
We tried to get it for the last 25 years, but Andreas remember all the discussions on this. Yeah.
And another question is, so you had a slide with the English-French systems. So it says that your English-French stock engine, e-translation engine, contains 237 million. I suppose is that sentence pairs, or?
Yeah, but that's just the general engine.
Yeah, no, I just wonder.
It's not trained on the Uramis data. It's just the general engine trained on available Opus and whatever.
Yeah, but just curious. Does that contain synthetic data, or is it just pure human data? Or
I don't know. I mean, I haven't really looked into that. But it comes mostly from Opus and whatever you find there. So I think that there might be more and more kind of machine translated data kind of sneaking into these Opus data sets. That's a possibility. For this engine, I don't know. I mean, it's supposed to be kind of clean parallel data, but probably it's not that clean.
Okay. Yeah. Okay. Thank you very much once again.
Thanks.
Miguel, do you want to sum up? I have a maybe a naive question, because if we look at the data and also the results that you're showing, we see very often blue scores that are maybe to the second or the third digit, and one is difficult for someone who is not in the test to understand what is the big difference between a system that does 48 with a system that does 49. Is this statistically meaningful, or we have, I think Mercedes put it, or yourself, Miguel, as clusters, and that 45, 49 is more or less the same order of magnitude?
Yeah, what I do to know the difference is using a statistical method called ART, approximate randomization testing. I think it was. What it basically does is selecting random sentences from it. I mean, the idea is to compare two systems between themselves. So it takes a random sentence and analyzes the scores at a segment level. And from that, I don't remember the details right now, but from that is able to test whether the systems present significant differences or not. So sometimes we see 1 point difference, which are significant. Sometimes it's a few decimal differences that can be significant or cannot. So it's not so straightforward.
Well, hopefully you can share with us some references if we want to go deep into this and see what's the.
So if you allow me one remark on this very question, is unfortunately I'm afraid that the meaning of blue score is even less helpful, as you can see from the significance testing. And as Shaba said earlier in his presentation, if we just switch a little detail, like the way punctuation is normalized, we sometimes get huge differences. But for a human user of this machine translation, I mean, whether it's straight quotes or curly quotes or whatever, isn't that interesting. But still, it gives sometimes a difference of 7 blue points, which is, I'm afraid there's a lot of, say, noise mixed in with the valuable signal it provides. So
yeah, that's right.
It's a problem. I mean, we all know that human evaluation also has a lot of problems, but
yeah, I think evaluation in general is a bit tricky in MT. That's why at least what we're trying to do is at least using different metrics, but still the same problems are inherent there.
Excuse me, can I add something to this issue? Yes, I wanted to say this anyway. So I think it would be great if we use some maybe more modern metrics like more SOTA metrics like COMET, for example, for evaluation? What do you think, Miguel, about this? And ideally, I think it would be great if we could use human evaluation, but of course I understand it's very expensive, but this would be great.
Yeah, I mean, ideally we would like to have a human evaluation, but we didn't have the resources or time to do that. And the other metric you mentioned, can you repeat that one, please?
COMET.
COMET. I'm sorry, but
well, it's a SOTA metric which shows, well, best results according to a correlation with human evaluation. So it showed best results on the WMT 21, the World Machine Conference on Machine Translation. So it's the statmt.org. So yeah, well, I think you should check it up.
Yeah, I will check it out.
Mm-hmm.
Yeah, thank you.
I can, yeah, I'll just send a link to the chat. Okay.
Okay, thank you.
Good. Other questions or issues that people want to raise right now? So maybe the big question for Miguel, Mercedes, and Paco is what do we do next? Is there enough interest to continue for a new round, or this is the end of it and we have seen everything that can be learned from this kind of initiative?
I would like to another round, but we need to choose a good challenge for these three, the third round. Maybe not to repeat the first two rounds, maybe another to add some, I don't know, maybe to use the monolingual corpora, I don't know. But I think it's I am in favor of a third round, yes.
So basically a technical challenge within the same domain of pandemic, COVID.
Yeah,
and,
of course. Yes.
Okay. What do the other colleagues think of that, particularly those who contributed with systems and spent some effort in the test?
I would be very interested to participate, actually. Maybe I could dedicate a bit more time to train again from scratch. So yeah, for me it's awesome because we can test our system and compare yeah, and define the framework,
Yeah. What about Alexander?
Yes, well, we can't spend a lot of time on these tasks, but well, it's very interesting, and I personally, and well, my company would be interested in taking part in the next round if it takes place. So yeah, that would be interesting, and we have some ideas we could check in the next rounds.
What about the others? Ivana, what about you? Would you be interested in having another round?
So yes, I would be interested, but I cannot really now tell 100% because I'm currently on my maternity leave and I'm not sure how my colleagues would. So yeah, it's a bit, I would be interested, but I cannot commit. I cannot tell 100%.
Okay, what about Rahil?
For us, I think these two rounds have been really interesting, but I guess for us to continue, if it's exactly the same kind of task it might be a bit repetitive. So I agree that for the third round, we might like participate if it's slightly different or it's a bit more focused on a specific task, still in the context of COVID, but maybe it's a bit more, the task is more specific and there's like some questions to be answered. Otherwise, we'll be basically trying the same techniques and there will be not much to learn.
Yeah, I agree.
Csaba, Andrea, what about you?
I mean, it could be interesting, the third round, and I would also support kind of extending the available provided data with some monolingual data sets, for instance, in the constraint category, remaining still in the constraint category, and even not very domain specific, and just leaving the task of selecting a good domain specific subset to the participants. That would be a possibility as well. But yeah, still a third round could be interesting.
Okay.
Yeah, it's very likely I think we will take part if it happens. Also for us, it was useful because we recently had a couple of new colleagues and they could learn how to build engines by taking part in this exercise.
Okay. So I think for the organizers now, I think Nicola, you will be the last one, or you wanted to step in now? Go ahead.
Yeah, I would like to step in just to ask a question about the logistics for the prospective participants. Is it okay to have this initiative organized as a standalone activity with its own schedule, which is somehow detached from the conferences in the field or whatever? Or would it be better to try to partner with some existing workshop or venue in order to align the schedules? I mean, was it an issue for you because it was somehow orthogonal to the normal flow you have, the scheduling, or was it okay?
In my experience, it's always more interesting when you have more participants. So if we can make this a part of a bigger event, and if that's going to attract more people, that will be much more interesting for everyone, I guess.
That's very, very true. But was the kind of scheduling organization a barrier, a plus, or neutral?
For us, the fact that it was not the same time with WMT, it was a plus. When it's colliding with WMT, it might be an issue because we might be participating in WMT challenges too. But if it's a part of WMT itself, we are also fine with it. We might just participate in that challenge of WMT itself. So it's not a big issue for us. So, but if it's really not part of WMT, it's part of another event, and if it's at the same time with WMT, it might be an issue.
Okay, thank you.
Yeah. Well, I guess some of us are also involved in WMT one way or another, so we can liaise with them. I think we have less pressure, at least from the outside. When we started this initiative, we want really to run fast to show what kind of results we get in the pandemic, circumstances. Here we can get together again, define the task in a very careful and crafted way, so it responds to some of the expectations. We can align it with one of the big events to make sure that we are still in the mainstream with what the community is doing. What about the key organizers? What about Valencia group?
Well, we have discussed this to put this the third round in the framework of the WMT. I think we have enough time in order to propose a new task for this workshop. Yes, I agree with you. We have more freedom with the current formula than the other one. We can try.
Okay, Vassili, what would you feel about having an extra round?
Actually, we would like to have an extra round, and just for your information, we have already expanded our process to all these medicines metadata for the other European languages and applied stricter filtering to provide the cleanest data sets. But this is about data. Regarding the workshop in the context of WMT or another conference, I think that many participants would, let's say, it will be difficult for the participants to choose in which workshop they will be participate. That's what I'm thinking.
You mean if we go for something combined with other big events?
Yes, but actually I don't know not to go, but that's what I'm thinking.
Yeah. Well, we see quite regularly new tracks in WMT, and I think it's a matter of discussing with the colleagues. Yes. If we feel that we have the data, we have the team, we have motivated participants. I have seen last time the less researched European languages where we had to do with Occitan, Catalan, and a few other languages. So I think it's a matter of how motivated we are, how enthusiastic we are about doing this.
Yeah, I agree, Khalid. This is just my, let's say, concern. That's all. Yeah.
Can I add something to this? Well, I think that, like Rahil said, partially, if it was the same event with WMT, I think I would have to choose tracks in which to participate according to my resources and computational. Yeah, just to mention.
Okay. Yeah, so we need to check carefully the tracks, but also the timeline of WMT. The idea, the interest of doing this outside is that we can schedule our events, our milestones in the way we feel appropriate. Yeah, so this is something we need to discuss with the organizers.
Yeah.
Okay. We still have some time as we planned. So if there is anything you would like to discuss, feel free to bring this up. Otherwise, we will just adjourn the meeting and get together with the organizers maybe soon to discuss the next steps, but also the next round. I see no hands, so Nicola, maybe you want to conclude?
Yes, it's a short conclusion, because basically it is really a big thank to everyone, to the team in Valencia and in Pangeanic who made this round happen, to the team of Vassilis who crawled and provided the data, and to all of you for the work you have done and for the interesting presentations and discussions today. And I mean, it is also, I think, rewarding to us to hear that you are interested and potentially willing to run for another round, and that also the format was basically okay. I mean, we just discussed would it be better to go with WNT or not, and no one was saying definitely you should do that way because that is the only way it could work. So I mean, we had to come up with this initiative to really face an unexpected, unforeseen situation worldwide, but we possibly have created the basis for something which can last and produce a sensible impact over time. So I can only thank you all very, very much for all of this. And see you next round, basically.
Yeah.
Thank you.
Do you want us to take a group picture the way we usually do when we meet face to face, or we leave this out? Let me see if I can.
I have a bigger screen, so I see all the tiles in one shot.
Good. So I let you do it, Nicola. I don't know if Zuzanna, Ivana are still with us with cameras.
Okay, guys, cheers. Let me take. Okay. Good. And does paste work? Yes, you should get it in the chat.
Oh. Thank you so much, everyone. Have a nice evening and take care.
Yeah. Thank you very much for the presentation and everything.
Thank you. Bye-bye.
Thank you.
Bye.
Bye, everyone.
Bye.
Bye.